Hi, yeah, so my name's Carl Williams. I'm one of the security engineers at Foursys. And had I foreseen WannaCry, this demo might be about the NSA leaked tools from the shadow brokers, fuzz bunch, but no, this is a slightly different take. We're actually going to look at USB keystroke injection. So it ties in very nicely with Graham's insider threat. We're going to look at how we can convince computers that we can plug in a USB device that essentially looks like a keyboard to any operating system that detects it, and we can start issuing commands to the system. Most of the time bypassing device control, because nobody really blocks keyboards in device control. I'm also going to talk about doing this on the cheap. You're probably well aware that you can buy devices like the Rubber Ducky. It's a commercialized tool you can go and buy. It has a very intuitive scripting engine. There's even a huge community around it. You can actually go and download a script that says, here's how to get a reverse shell just by plugging in a USB device. But they're like £50. It doesn't sound like a lot of money, but it's, if you want to make these devices disposable, where you just drop them around certain places and just hope that somebody might plug them in and have your malicious commands executed, then you want something a little bit cheaper. So what I have here is a DigiSpark. So this is a Arduino programmable sort of development board. They've been about for quite a few years now. I think 2012 they were released. And they're designed to get kids into coding. You can get some GPIO headers in here, and you can sort of code up the Arduino-based board on here and get it to do various things like turn on LEDs, control a display, all kinds of fun stuff. But you can also use this maliciously, of course, like you can with most things. And this kind of attack actually originated, I believe, I need to do a little bit more research on this, so just don't quote me on it, but Hyundai actually used this kind of attack vector as a marketing tool. So they used to essentially give out a key that would start executing keystrokes on your computer and take you to the Hyundai website, and they didn't think that people might use that maliciously. So yeah, we're going to look at this. It's exactly this is actually a fake DigiSpark. You can tell that because it's basically Rev 3. They didn't make a Rev 3 version. So this is from good old eBay, probably from China. I bought 5 of these for the equivalent of about £4. Not much at all. So let's look at this and see what we can do. So on the left-hand side of the screen here, we've got our Arduino development environment. And I just have to point out here, there's a lot of praise that should go to the guy behind Arduino. His name's Satonic. You can follow him on Twitter. All kinds of cool stuff on his on his blog. But he's the guy behind Arduino. Being able to convert these devices to do various different things. And it's good that this information is out there. I appreciate that. Obviously, it teaches the bad guys how to do stuff, but it also teaches us and everyone else that these things exist and can be done. So that's almost one of the first defenses against this attack, knowing it actually exists. But on the left-hand side, you can see how simple the code is to this program. Essentially, we're including a library for this particular board. It's a DigiKeyboard, which basically makes this think it's a keyboard. We've got some short code of how to control the LEDs. There's some blinking LEDs on here. So once our code or payload has been dropped, it's just going to flash the LEDs to let me know that it's finished. And then we've got some simple commands here. We've got DigiKeyboard, send, keystroke, keyr, mod GUI left. Does anyone want to have a guess at what that actually does? No? That simply sends a Windows key and R to the host. And what does Windows key and R do? Brings up the run prompt. And then we have DigiKeyboard print. And essentially, we can type whatever we want in here. It's going to send that, whatever we type, to the run prompt and execute it. So if we were to do something like, I don't know, as a test, let's bring up Notepad. And then something like, surely this is bad. Call me Shirley. OK? So let's put that in there, for instance, and then let's code this up. Let's actually send this to our device. So it's asking me to plug in the device now. It will time out after 60 seconds. Let's do that. It takes a few seconds, and it's done. OK, so I've now unplugged it. I can now plug this in on any Windows system that allows users to bring up the run prompt, and it's going to execute exactly what I just told it to. So let's have a look and see. Just going to plug it in. Takes a couple of seconds. No hands. And if the demo gods are with me, it's done that automatically. Nothing that I've typed at all. So how could we use this maliciously? Of course we can. So let's do something a little bit more interesting. I did say that I'm doing this on the cheap, which I am. So this little device only has 6 kilobytes of storage, including the space required for its libraries to make it pretend to be a keyboard and all kinds of stuff like that. So we can't issue lots of stuff in here. We can't make it do something very complex. If I was to create a PowerShell-based payload with, say, something like MSF Venom, which is part of the Metasploit framework, and I do also want to highlight how simple this kind of stuff is. I mean, you just need to know how to Google, know a little bit about syntax, and know what your end goals are, and you can really research this kind of stuff in a day and start doing this kind of thing. So, I mean, I could generate a malicious payload with MSF Venom. We could do something like this. Oh, if I spell reverse right. lhost being my attack machine. Lport being what port I wanted to connect on. I'll do something like 443 because, you know, most people have 443 outbound open. You know, we let people surf the internet. We let people get out on the internet. And I could just specify that I want to issue this in a PowerShell command. So let's just run that and see what we get back. Loads of stuff. Far too much for our poor little DigiSpark. There's just too much here. This is because of the way that they've, you know, attempted to hide this from any security product you might have on your laptop, your antivirus, that kind of stuff. We've essentially encoded the entire command, and within the code itself, I mean, if we were to look at this, if I was to just, this is encoded in base 64, so if I was to look at this, paste this in, we can see, you know, a little bit easier what's going on. And you can see there's another layer of encoding here. There's also some compression. You can understand why security products might struggle with dealing with this kind of attack. But still, it's still far too big to put on our poor little DigiSpark. So we're going to have to go a different route. We can host a payload. PowerShell supports all kinds of little commandlets that allow us to go and fetch a payload. You know, have something hosted, tell PowerShell to go get that payload and execute it. So we can do something like that. Let's do that. So I'm going to actually start MSF console up, which is the front end for Metasploit. And bear with us, we're expecting a nice, funny banner like we normally get. Changes every single time. So one of the modules inside here is a web delivery mechanism. We can use exploit multi-script web delivery. If I bring up the info on this, we can see that we can target Python, we can target PHP, and we can also target PowerShell. It wants a few options from us, like where are we going to host this malicious payload? What port do we want to host it on? Do we want to use SSL? What payload do we want to inject into this? So let's set this up. I need to set the target to 2 because we're going to use PowerShell in this example. I'm going to choose the same payload that I just generated. So Windows, interpreter, reverse TCP. I need to set the local host, my laptop. Let me just check that that's right. Yeah, we're all good here. Set out port 443. I'm also going to set a couple of other options. This one's set exit on session as false because once the job's running, I don't want it to kill my server just in case I want to infect other people. And then I can exploit. So this is now running a local web server on my host in this example. And it's also given me the PowerShell to essentially call back, grab the payload, and execute it on the victim. So if I grab that, oh, didn't want to do that, party for you, and paste this into my IDE here, replace Notepad with that, and then we can comment out these other lines. We don't really need these anymore. And we've got one command being executed, and that's it. And we're ready to go. Let's upload that to our DigiSpark. It's ready for it. A couple of seconds later, and we're good to go. So let's just clear this window so we can see exactly what happens. So I've got my web server up, it's listening, it's ready for the connection, it's ready to deliver the payload. It's now just waiting for somebody to plug this in and have it run. So let's do that, plug it in. See what happens. We expect something to appear in this right-hand window here. There goes our command. Delivering payload, sending stage, interpreter session 1 opened. And we could have this anywhere. We could have this in AWS. We could have it on the net somewhere. It could be absolutely anywhere. And now I have full command and control of this particular host. If I list my sessions, I've got one there. I can interact with that session. I can bring up some information based on this computer. If we have a look at some of the things I can do, I can record the microphone. I can start key login. I can kill processes if I've got permissions. I can execute things. I can clear the event log again if I've got permissions. Even a webcam snap. I can do a lot with this particular framework, essentially. And the key thing to take away from this is I am running in the user context. If your user that plugs this in is a local administrator, I'm a local administrator. If they're a lockdown user, I'm a lockdown user. I'm going to have to work a little bit harder to sort of escalate my permissions and do a bit more damage. So just to prove that we are in control, I can drop a Windows shell here. There we are, into PowerShell. I could even write some PowerShell. Let's quickly do that. I'll do something like this, and then equals new object, com object, shell. A. And there we go. I just wanted to sort of highlight that we're in control of this system. We can execute commands. We can do cool stuff, essentially. So, defense against the dark arts here. What do we do? To be honest, defense against most insider threats is very difficult. It is a hard thing to do. I'd like to probably concentrate on a few things here. One of them is user education. Obviously, your users could just plug this in themselves knowingly. Obviously, we want to constantly highlight to our users, do not plug things that you find off the street or in the car park into your computers. That's a given. But I also want to focus on things like containment of the hacker or the attacker, if they do actually still manage to do this on your computers. We want to make it as difficult as possible for them to move laterally in the network. This means making sure that we're enforcing things like principle of least privilege access. Let's not allow people to just easily get administrator privileges, which makes it a lot easier for the attacker to do more things, to enumerate more stuff. And then the other aspect of it is the visibility, being able to spot that something strange is going on in your network, have the SIMs in place, the network access controls in place that we can spot this kind of attack quickly. If this user's endpoint is all of a sudden trying to access other endpoints around the business and this is not normal, then we want to be alerted that this is happening, because the quicker we can jump on something like this, the better we can defend against it. And yeah, that pretty much sums up my talk. I hope that's been useful to you and interesting at least. You can come and talk to me anytime if you want to, anything you want to ask. That's great. Perfect. Thank you.